Imagine you have millions of document chunks. When you ask a question, the AI doesn't scan every sentence looking for matching words. Instead, it searches something completely different, vectors. Every chunk has already been converted into a numerical representation called an embedding. These embeddings allow the system to search by meaning instead of just matching text. Traditional keyword search compares words and phrases. That works well when the same words appear in both the query and the document. But language is flexible. One document might say database connection timeout, while another says application cannot reach PostgreSQL. Humans immediately recognize they describe the same problem, but computers see different words. To compare meaning efficiently across millions of documents, we need another representation. An embedding is simply a list of numbers generated by an embedding model. Instead of storing the sentence database connection timeout, the model converts it into a vector containing hundreds or even thousands of numerical values. You don't need to understand each number individually. What matters is that the entire vector represents the meaning of the sentence. Similar meanings produce vectors that occupy nearby locations in vector space. Imagine every sentence in your knowledge base is placed somewhere inside a massive, multidimensional space. Chunks discussing databases naturally cluster together. Networking documents form another cluster. Authentication documents form another. When a new question arrives, its embedding is generated and placed into the same space. Instead of searching for matching words, the system simply asks, which existing vectors are closest to this one? Embeddings are usually generated during document ingestion. First, the document is split into chunks. Each chunk is passed through an embedding model. The resulting vectors are stored inside a vector database together with metadata such as document ID, source, permissions, or page number. This process happens once, not every time someone searches. When a user submits a question, the system sends only the query through the same embedding model used during ingestion. This produces another vector inside the same semantic space. Because both the stored documents and the query were created by the same model, their vectors can be compared directly. The vector database now searches for the nearest neighbors rather than matching text. Once the query vector is generated, the vector database calculates which stored vectors are closest. Several mathematical techniques can be used, including cosine similarity, Euclidean distance, or dot product, depending on the embedding model and database. The closer two vectors are, the more similar their meanings are likely to be. This allows the system to retrieve relevant chunks, even when no keywords overlap. A common question is whether different embedding models can be mixed together. In production systems, the answer is usually no. If documents are embedded using one model and queries are embedded using another, the vectors may occupy completely different semantic spaces. The nearest neighbor search becomes unreliable because the mathematical relationships no longer align. The complete retrieval pipeline now becomes clear. Documents are split into chunks. Each chunk is converted into an embedding and stored inside a vector database. When a user asks a question, the query is embedded using the same model. The database finds the nearest vectors and returns the most relevant chunks. Those chunks are then passed to the LLM for reasoning. If you remember one thing, remember this. Embeddings transform language into mathematics so that AI can search by meaning instead of words. Hope you enjoyed the sketch. We'll see you in the next one.